Hi all, today I'm going to share to you all the theoretical part and the definitions in a mechanical wave. For the first one, what is meant by a wave? A wave is a traveling disturbance. It carries energy from one place to another. State two types of waves. Give two examples for each type. So one is mechanical waves require a medium for their propagation. Examples of mechanical waves: sound waves and water waves. So these are the two examples for mechanical waves. Whereas for electromagnetic waves do not require any medium for propagation. It travels in straight line. So some examples of electromagnetic waves are written here: visible light, radio waves, X-rays, and all the waves in electromagnetic spectrum. We call it electromagnetic waves. State two types of mechanical waves. One is transverse wave. For transverse wave, the oscillations of the particles in the medium is perpendicular to the direction of wave propagation. Whereas for longitudinal wave, the oscillation of the particles in the medium is always parallel to the direction of wave propagation. This is the equation for progressive wave. Y is the displacement of the particle as a function of x and t equals to a sine in bracket omega t plus minus kx. Kx, which is equals to phase angle or phase difference. From this progressive wave equation, we can define all the symbols. A is the amplitude of the wave, omega is angular frequency, k is the wave number, x is the distance from the origin, t is the time, and phi is the phase angle. Let us see the important definitions in this equation. We start with amplitude is the maximum distance from the equilibrium position for particles in the medium, followed by angular frequency. It is similar to the angular velocity, which is equals to 2 pi f. F is the frequency. Frequency is the number of complete oscillation per second for particle in the medium, or the number of cycles or wavelength produced in 1 second. The SI unit is hertz or per second. This is the formula for frequency. And T is a period. Period is the time for a complete oscillation. The unit for period is second. Followed by wave number is defined as k equals to 2 pi over lambda. Lambda is wavelength. 2 pi is the constant value. Wavelength is the distance between successive particles that oscillate in phase. So this is the distance between two successive particles, crest, mid crest is wavelength, or the trough, mid trough also is a wavelength. Crest, mid crest, or trough, mid trough. And this is the maximum distance from the equilibrium position for particles in the medium. We call it amplitude. Particle B is in phase with particle C. Particle P in phase with particle Q, particle S is in phase with particle T. So this is, we call it properties of waves. For the wave number, the unit is per meter, and the wavelength, the unit is meter. Now I'm going to brief on the sign of positive negative in this progressive wave equation. Positive sign shows the direction of wave propagation is negative direction, or the wave propagation is from right to left. And the negative sign shows the direction of wave propagation is positive direction, or the wave propagation is from left to right. In this section, we're going to see clearly the definition for phase angle or phase difference, which is part of progressive wave. What is meant by phase difference? The phase difference between two particles in the medium that are separated by a distance lambda is 2 pi radians. Hence, the phase difference phi between 2 points by a distance of x is given by phi equals to 2 pi x over lambda, or 2 pi x per unit lambda of wavelength. So phi equals to kx, k equals to 2 pi over lambda or wavelength. For wave speed is defined as the distance travelled by a wave profile per unit time. So now you can see how a progressive wave profile moves a distance of lambda in time t. So the v speed of wave equals to distance over time, which is equals to the distance is lambda over time. So time here is a period. So period is a time for a complete oscillation, which is equals to 1 over f. So v equals to lambda times f. F is a frequency. We have to understand that the wave speed is not equals to speed of the particle. So the speed of the wave is lambda f is not equals to positive negative omega square root of a squared minus x squared. Let us try to do this question. A progressive wave equation is given by y into x and t, which is equals to tan sine in bracket 2 pi t plus pi x, where x and y in meter and t in second. A. Calculate the amplitude, angular frequency, period, wave number, wavelength, and the speed of the wave. We can get three values of amplitude, angular frequency, and wave number once we compare the general equation of progressive wave with the given equation. So the amplitude here is tan meter, angular frequency is equals to 2 pi radian per second, and wave number k equals to pi per meter. So you can get the three values straight away from the equation. A equals to 10 meter, omega equals to 2 pi radian per second, and the wave number k equals to pi per meter. To find the period and frequency, we can use the formula from angular frequency. Omega equals to 2 pi over t, t equals to 2 pi over omega, omega itself is 2 pi, then we will get the period is 1 second. And the frequency f equals to 1 over t equals to 1 over 1 hertz. Wave number, you can get it from k equals to 2 pi over lambda, and from this wave number we can find the wavelength, where wave number is pi per meter from given equation k equals to pi. So wavelength equals to 2 meter. And finally, the speed of the wave, which is equal to f lambda. F is 1 over t, which equals to 1 hertz, times lambda is 2 meter, and finally you will get 2 meter per second. Simple like a bubble without giving you any trouble. For section B, sketch the graph at t equals to 0 for this range. From the progressive wave equation, we substitute t equals to 0. Then it forms new equation, which is y in x displacement equals to tan sine in bracket pi x. So from the equation, the wave number is pi per meter and the wavelength is 2 meter. Distance for one wavelength. Before we sketch the graph, we have to know the starting point of the graph. So from this equation, when x equals to 0, y equals to 0. So the starting point for the graph is at origin O. So this is the starting point of the graph. So you have beautiful sinusoidal graph. For one wavelength, 2 meter, which is the amplitude is 10 meter and negative 10 meter from the equation. Thank you for watching this video. Thanks a lot and thank you to the Lord.